Okay, good morning, everybody. We're starting our new video, 1.2, page 7 of your note packet on composition of functions. So go ahead and pause, get yourself ready, but I'm going to jump right in to keep this as short as possible. So a composition of functions is when two or more functions are combined to form a brand new function. So the notation looks like this. F of g of x, that's how it's read. Or that little tiny circle, notice it's not a closed circle. It's not multiplication. It's not f times g. It's f of g of x. And these are both different ways of writing the same thing. It's kind of like if you did composition of transformations back in geometry. I'm not sure if you guys still do that anymore. But it's like a reflection of a translation. So it would be you do the translation first, followed by the reflection. It's the same thing with this. We do g of x first, and then whatever the output there is, then we do f of whatever that output is. And you'll see what I mean in a second. So the of comes first, f of g of x. The inside comes first. It's not just as simple as multiplying the two functions together. So let's look at an example or two. So given the functions f of x and g of x, and remember you can pause if I went too quickly there. There's f of x, there's g of x. I want you to evaluate the following. Maybe we'll skip b and d. We'll just do these two on the left for now. All right. Well, I guess I can't do it. Oh well. Okay, so f of g of negative 3. So what's happening is we're just doing g of negative 3 first. And this is just straightforward, just making a substitution. So g of negative 3. And here's my g function. Be careful here. This is one of those little autopilot moments. We have to be careful with our algebra, with our order of operations. So this is not saying negative 3 squared. This is saying negative 3 squared. All right, so that's a very important big difference when we're doing our compositions. We're doing any substituting. Negative 3 squared is 9. 9 minus 9 is 0. All right, so we take that 0. G of negative 3 is just 0. All right, remember we talked about this equal sign is really important. It means these two are equivalent. So G of negative 3 is literally just another way of writing 0 in this example. So since G of negative 3 is 0, I can just substitute that 0 in for G of negative 3, which means we're just looking at f of 0. Here's my f of x function. F of 0 is 2 times 0 minus 5, which is just negative 5. All right, so f of g of negative 3 is just negative 5 once we evaluate it and substitute. So here's where we can take a little shortcut. Let's say I wanted you to do a bunch of these. So there will be times where you need to use these composition of functions. But what if I wanted you to find f of g of 7, and f of g of 10, and f of g of negative 30, and f of g of 0.5? We don't want to have to do this all every time. So we can just make a rule for this. We can just kind of summarize it. We can do f of g of x. And as always, x just represents any number. It's a variable. It can be anything. So we can just use this variable, this g of x, plug it into f of x, and then see what this rule would apply for any number. That was in a good sense. What would apply to any number given this composition of functions? So f of g of x. G of x is x squared minus 9. So what we're doing is f of x squared minus 9. So like we talked about in class, when I have questions like this, and it's a little harder to substitute when it's a big term like this, let's just go back to our basics. F of 1 is 2 times 1 minus 5. F of 7 is 2 times 7 minus 5. F of R16 is 2 times R16 minus 5. F of smiley face is 2 smiley face minus 5. F of x squared minus 9 is just 2 times x squared minus 9 minus 5. All right, so just substituting whatever this is into x in our f of x function. So this leads us to 2x squared minus 18 minus another 5. I'm going to do that all in my head. So right there, is f of g of x. So watch why this is so helpful. Now if I wanted to go back to my original question and do f of g of negative 3, I can just put negative 3 in for x here, just to check our work. Negative 3 squared is 9. 2 times 9 is 18. 18 minus 23 is negative 5, just like we expected to get from up top. So that's a nice kind of a shortcut. So there's how we do our compositions. So why don't you guys practice this one on your own, see how you do. I'm going to pause my screen. You can try yours out on your own, and then when I unpause, I'll have some work there to see how you did. So go ahead and pause now. Make sure you got the hang of it. So there we have it. Just be careful. This one I flipped around on you. This was asking for g of f of x. So I put f of x, substituted into g of x, and we just end up with a nice 5x minus 2 there. All right, so that's a really good a good example of an inverse function. So let's flip. And my labels came off on this page, so before you start, make sure you label the dashed function as g of x and the solid line function as f of x. We can also do this composition stuff graphically. All right, so looking at this very first one, I'm asking you for f of g of negative 1. So we start from the inside first. We can just evaluate g of negative 1. So this is saying when the x value is negative 1, what is the y value for my g of x function? So g of x, my dashed line, here's negative 1. So g of negative 1, when the x is negative 1, my output is negative 2. So now we take that output, and that becomes the input of our composition, of our secondary level of this composition. So g of negative 1 is negative 2, and then we look at f of negative 2. So here's my f of x function. When x is negative 2, my output is 0. So there's my final answer. Make sense? All right, so why don't you pause again, try those next two out, make sure you got the hang of it, and then we'll do one last little thing, and then we'll be done. Okay, so as I was doing that, I realized my 5 got cut off here. So g of 5, g is here. G of 5 was supposed to be 0. So that was my bad. It got cut off a little bit, but hopefully you understood what I was getting at. Okay. So we can go on and on with this. We can actually do a composition of 3, 4, 5, however many functions we want. So this is saying f of g of h of x, f of g of h of 2, where we do the same thing. We would work from the inside out. So if you want to practice this, you can. So we would first take g of h of x. So h of x is 5 minus x. G of x is x squared minus 2. So we would have 5 minus x squared, right? I'd substitute right in for there, minus 2. So we can simplify, we can expand. So if you want to pause and try this out, we'll take whatever this answer gets us. We'll take that and we'll plug it into f of x. So my final answer, so pause now if you do want to try it. Do I have enough parentheses? I need one more. There we go. G of f of g of h of x comes out to be 3x squared minus 30x plus 72. Okay, so then the same thing would happen. If I wanted to do f of g of h of 2, I could do the different layers. Again, I could do h of 2. I could find out what that is. I could put that into g of x. I could find out what that is. I could put it into f of x. Or we could just take this 2 and use the composition we already made and plug it in, substitute it into the x's in that function. All right, so hopefully we are feeling confident with that. Here's your homework. So given the functions f of x and g of x, I want you to evaluate the following. So I want you to find g of f of negative 1, g of f of negative 3, and g of f of negative 4/3. So you can put those values that you found right there. So I want you to keep in mind when you're doing this, the domain restrictions we talked about last class, okay? So come up with a hypothesis first. Maybe before you even plug these in, I think that's what I'd like you to do. So what do you think is going to happen before you evaluate those? Take a little guess. If I put in -1, if I put in -3, if I put in -4/3, does anything stick out to you? What do you expect to happen? All right, then I want you to actually find those numbers. So what is g of f of -1? What is g of f of -3? What is g of f of -4/3? So your Google form will be tonight to kind of let me know what you discovered, let me know what you think, let me know what you anticipate coming up next class. All right, and then I want you to try to find the actual composition of functions, g of f of -x. If you want to play around with that, you can. We will start here with our bell ringer next class.